Hey Thinksters, what's up? It's Adam, and in today's video, I'm going to be talking to you about Matplotlib Subplot. It is an incredibly helpful function. You can use it to create graphs of unlimited complexity, and it really takes you from being a beginner to being a really solid intermediate, and if not, advanced coder. So let's just dive straight in with an example. So first off, I'm using today and from now on the wonderful Jupyter notebook. Really recommend that you check out using this if you are creating blog posts or doing some analysis. It lets you write and it lets you code at the same time. So to create a subplot with any number of rows and columns, we use the plt.subplot function. Now note, it does not have an S at the end. There is one that is called plt.subplots, and I'll talk about that in another video. But plt.subplot takes 3 arguments. They are all integers and positional only. That means you cannot use keywords to specify them. So they are n rows, number of rows you want, n cols, the number of columns you want, and index. So that is the subplot you want to select that you are then going to draw on. So for example, and remember, a subplot in Matplotlib is always a grid. So it will be some kind of grid of, in this case, if we do plt.subplot 311, that has 3 rows and 1 column. So it's a 3 by 1 grid. And then it selects the subplot with index 1. So quick overview. After plt.subplot, you're going to code your plot as normal using the plt.functions that you know and love. Then you select the next subplot by increasing index by 1. So for example, plt.subplot 312 would be the next one after this one. And then once they've all been plotted, we're going to call plt.tightLayout, which ensures that no parts of the plot overlap. And finally, as is pardon me, with all Matplotlib functions and plots, call plt.show at the end to display your plot. So let's get into it. So first off, we're going to import the necessary modules, and something this is I like to do that you don't have to do is we are going to set the style to Seaborn. So classic Matplotlib import, matplotlib.pyplot as plt, Seaborn as SNS, and then sns.set gives you that lovely Seaborn style. And then of course, NumPy, import NumPy as MP. First off, going to generate some data. So the linear data, all of this using list comprehension. So x for x in range 5. That's the numbers 0, 1, 2, 3, and 4. Square, x squared for x in range 5. So that's 0 squared, 1 squared, and so on. Cube, x cubed for x in range 5. Again, 0 cubed, 1 cubed, 2 cubed, etc. So the first one, we're going to do a 3 by 1 grid. We're going to select the first subplot. So 3 rows, 1 column, index number 1, and that is the first one. It does 1 base indexing for some crazy reason, but there we go. And then we're just going to do a simple line graph, plt.plot the linear data. Then we're going to do a similar thing, plt.subplot 3 rows, 1 column, and we're going to pick the second one there, plt.plot square. Finally, third 3 by 1 grid, the third subplot, so it's 3 rows, 1 column, selecting the third one, and then plt.plot cube. And then we're going to call plt.tightLayout, plt.show, and here we go. What a lovely plot, generated in just a few lines of code that I think is quite intuitive once you get used to this. And we'll be going over, we'll go over it in a bit more detail, but there's just a very quick way to do it that can apply to any shape. Obviously, you can just change 3 and 1 to any kind of shape you want and fill them in. So let's get into this in a bit more detail. So we've already covered this, n rows, n cols, and index. So if you want a 2 by 2 grid, you're going to set n rows to 2, n cols to 2. And note that the number of subplots you have in the grid is like n rows times n cols. So a 2 by 2 grid has 2 times 2 equals 4 in total subplots. Likewise, 3 by 1 has 3 times 1, which equals 3 subplots in total. So the index is the subplot you want to select, and the code you write immediately after that is drawn on that subplot. So yeah, indexing starts from 1, not 0, and continues left to right in the way that you read. So for a 2 by 2 plot, the indices are, this is number 1, top left, this is number 2, 3, and 4. So it's the same way that you would read, which I think is quite intuitive and simple. And you may be thinking, well, what if I've just got columns? Well, then we start at the top, and we're going to go from left to right. Well, there's nothing there, so we just go to the next one, 2 and 3, like that. The arguments are positional only, so you can't pass them as keyword arguments. If you try and do something like this, you're going to get an attribute error, has no property n rows, but that's okay. One cool thing, though, that you'll probably do all the time is not include the comma, because it's optional. Only if each value is less than 10, but it's unlikely going to be creating like 10 by 10 grids, so it should hold you for quite a lot, considering that like a 9 by 9 will have 81 plots on. So these are equivalent plt.subplot 3, 1, 1 and plt.subplot 3, 1, 1. So here is the default kind of layout that all your subplots will, like the code for all your subplots will take. So it'll just be, you'll think of what kind of shape do I want. So in this case, 3 by 1, and then you'll just write plt.subplot 3, 1, 1, and then you plot your first one here, and then increase this. So this right-hand index is going to be increased. So you can see here 1, 2, 3. Pardon me, and we just plot the first, second, and third subplots there, and of course call plt.show at the end. So this is what you get, which is okay. It's not bad for default. But one issue, for example, is here the x-axis labels are quite hard to read / impossible to read. So we've got a few ways to solve this. First, you can manually adjust the xticks with Matplotlib xticks function. So plt.xticks. Hopefully you know this already. You know this function anyway. And I had a little play around, and I realized so you can't actually turn them off, which is what I tried to do first. But you can just make them transparent by setting alpha equals 0. That's the level of transparency between 0 and 1. Or you can move them and decrease their font size with the position and size arguments. So this, we're going to follow this exact same schema. So here we're going to make the xticks of the top 2 subplots transparent. So it's the same code, but we're adding this line in plt.xticks, alpha is 0. And then the final one is we're not touching it. And then I've actually added a title here with plt.subtitle, standing for super title. We'll get onto that a bit later, just to show the difference. So here, can't see any xticks on the first or second columns, so it is worked. Second thing we can do is we can move the xticks, decrease their size, and move them for all the plots. So here, I'm going to set plt.xticks, the position is 0 and 0.1, and the size is 10. So these are positions like relative to these subplots. And then the size is obviously like a fraction of the font size, so we're just decreasing it. I think the default is 12. It might be 14 though. So yeah, we're going to manually add all of that, and again, add another subtitle, and you'll see that these are all smaller and all readable now. So the way I found that really was just by playing around, which works, but you can't automate them, which is really annoying for us programmers. Like, you don't want to be manually adjusting everything. That's not why we became programmers. So, and also, you may realize that you're going to have this problem every single time if the default settings gave us this problem. Thankfully, though, Matplotlib have thought ahead, and they created Matplotlib tight layout. Yay! So, calling plt.tight layout, it automatically adjusts quite a lot of the plot to make sure they don't overlap. So it adjusts the axis labels. That's like if you want to put like, this is effort, and this is like score, or this is time, and this is value of the stock market. If you label them. Tick labels, which we already saw, so these are these numbers here. And then titles, so like anything on top, like this is showing the S&P 500 index over 10 years, something like that. Now they do say in the docs that it is experimental. It's not perfect, but it almost always does a really, really good job. It doesn't work too well or really at all with legends or color bars, and you'll see how to work with them later. To be honest, if you're making like complex plots with legends and color bars, I would recommend you learn plt.subplots with an S, because it's more advanced and it works better with them, basically. But I've got an article on that. I've got a video on that, which you can check out too. So let's just quickly see the most basic example without any labels or titles. So look, we're going to look, because we can do this as a Jupyter Notebook, amazing. So we're going to run this. This is the default without tight layout. It's the exact same as before. And then I'm pressing Command and slash to do this, by the way. If you didn't know, I can add a comment. And then I'm going to run this, and boom, there we go. We can read every single one of our plots now, and all the x-axis, all the if we put a title in there, we can read that as well. Let's just add in a quick title now, example, and see what happens. You see, there we go, it gets added there, and let's put in another one here. Hello. Run this. Excellent. You see, but one issue you may think is that yes, we have all this info, but now the plots are very thin. Very thin. Let's comment these out. And we'll see that you can see a lot more of the plots here without that. So I'll show you how to fix that later on. Fear not. We'll show you how to fix that right now. So there is a pad keyword. So that accepts a float in the range 0.0 to 1.0. So that's a fraction of the font size. And yeah, so here we're going to do the exact same, but set pad equals 0.1, and you can see it's much better than this. Like pretty much all the space really is taken up for like the plots as can be. So that's really what we want, because obviously the plots are what we care about. We just need the labels just to kind of help us along. So I'm going to be using plt.title layout in every single plot, and I just recommend you do as well. It's just a really easy, quick check that makes your plots look great. It does accept some more arguments, but just check out the docs for them. That and pad will do you for most of them. All right, let's have a look at how to add titles. I've already kind of quickly showed you that. Plt.title function, just add it underneath the subplot that you want, and then it will go there. So, and obviously that corresponds to the index. So first title, index 1 goes here, third title, index 3 goes here, and so on. And there we go. You can also add an overall title. So that is the plt.subtitle. So that stands for super title. So this here is the exact same plot that you've just seen. And then adding a subtitle, just call that again. I like to put it in here right at the bottom. And then it's called My Lovely Plot, and you'll see that it gets added in here. Now note that this is a bit tight in here, like My Lovely Plot on 1.0 there. So you may want to do a bit of moving about. You could change the font size, you could change some of the padding, but default works really well. All right, let's get into changing the subplot size. So one thing you can do is change the height, but let's go into it in detail. So you can change the size of the entire figure or the size of the subplots themselves. So first, let's look at changing the figure, but even before that, what is the figure? So I'm going to quote here the anatomy of Matplotlib. So that is a really good Matplotlib tutorial. You can check it out down here in the bottom left of my screen, github.com/matplotlib. Anatomy of Matplotlib is gone now. So they define the figure as it is the overall window/page that everything is drawn on. So you can have multiple independent figures, and they can contain multiple subplots. So basically, the figure is like the blank canvas that you paint all your plots on. It is this white space behind. And a subplot is obviously these things that get added. Now, most normal, in quote, plots will just have one figure, and then they'll have one subplot, taking up the whole space. But with a subplot, you have multiple subplots, but you can only have per image one figure. And so if you're happy with the size of your subplots, but you want the final image to be larger or smaller, we're going to change the figure. So we do this right at the top of our code with the Matplotlib figure function, since that's literally our building blocks. It's like the blank canvas for the artist. So that's the thing we have to start with. So here we go. plt.figure and then fig size equals 3, 6. So that makes the figure size 3 inches wide and 6 inches long. And then we've got a subplot here, 2 rows, 1 column, index 1, and then 2 rows, 1 column, second one. Show it, and now you can see it's much longer. If we, what am I doing? If we took this away, then the default is to look like this. So we have changed the output here to something that's kind of long and thin. So fig size accepts two numbers, tuple of two numbers, width and height of the image in inches. It's not in pixels. Be careful. I read a Stack Overflow answer that was like, he wanted to make an 800 by 600 pixel one, and he put 800 by 600 in, and it crashed his computer. So don't do that. It's in inches. Again, kind of showing its age a bit, but it's fine. So let's see, but then you can also do a really nice one. If your brain doesn't work in inches, like mine doesn't, you can use the aspect ratio. So you can, here, we're going to make the figure twice as long as it is wide. plt.figure, fig size equals plt.fig aspect. So we set that aspect to 2 to make it twice as long as it is wide, and then we have the same here. And now you see it's like that. We can even, let's add this to 3, so it's 3 times as long as it is wide, and you'll see that it's much bigger. But we'll change it back now. So I personally really like Matplotlib fig aspect because that's how my brain works a bit more. I'm like, well, I want this to be kind of twice as wide as it is long, or this size or whatever. So yeah, really good. Just remember the aspect ratio is height over width. And you can remember that by recalling that height comes first in the alphabet. Now, right, so we know how to change our figure. Let's look at how to create different sized subplots on one figure. So we're going to create this shape, right? So before we've been creating like these, which are the same size, or we had these guys, and these all take up the exact same amount of space. Pardon me. But now we're going to create different size subplots, which is really cool. So the first thing is that you need to know what you're aiming for before you start. So I actually made this in Google Slides. You can do like PowerPoint, Google Docs, whatever, sketch it on a piece of paper. If you know what you're aiming for and you know the fraction of space they take up, it just makes it so much easier. And look, like if you actually look at it, like this one is clearly smaller than this, but I've just labeled it as an 1/8 because, you know, it's okay. It's just a sketch. It doesn't matter. So let's go through this. The way you do it is you're going to look at the subplot you want and imagine it as part of like an equally spaced one. So for example, this one, we're going to make this big one first, and that is actually part of, if you think of it, 1 row, 2 columns, and it's the second index of that. So to select it with plt.subplot, we're going to set index 2 of a 1 row, 2 columns subplot. So that is plt.subplot, 1 row, 2 columns, index 2. Awesome. The next one is index 3 of a 2 by 2 grid. So that is plt.subplot 2, 2, 3. And then the final 2, because it was a quarter, the final 2 are these top 8ths. So if you imagine it, like you can imagine like 1/8, 1/8, 1/8, 1/8. Okay, cool, so that's half, and then 1/8, 1/8, and then obviously it's just going to be the same on that side. So it is a 4 by 2 grid, and we want the top 2 left-hand ones. So if you think of that, it's a 4 by 2, and these are the indices going along like that. So we need indexes 1 and 3 of a 4 by 2 grid. So that's 4, 2, 1, 4, 2, 3. And putting that all together, we're just copying and pasting that there, calling a bit of tight layout, calling show, boom, there we go. And then you can just plot on these as normal. So let's just do a quick line plot here. And there we go. So that is 2, 2, 3. So that is this bottom left-hand one. How nice is that? Very good. So you just kind of take it from there. Making that shape is the hardest bit, and then actually adding the plots to it is fine. It's just the same as normal. Now, you may have noticed all of these, this is a half, a quarter, an 1/8, and an 1/8. They all took up 1/xth fraction of space. Like 1 over half, quarter, and 1/8. Can we create this shape where it's like 2/3 of the space is taken up by this and 1/3 of this? And the answer is that unfortunately, no, we can't do that with plt.subplot. But it's impossible to create anything in Matplotlib, so you can do that, and I'll show you how to do that in the Matplotlib subplots function. So please check out that article if you're interested in that. Moving on, if you're not happy with tight layout and you want to kind of change the spacing of it, manually adjust it for whatever reason, you can do so with the plt.subplots adjust function. So it has 6 optional, pretty self-explanatory keyword arguments. They all accept a float in the range 0.0 to 1.0, and they are a fraction of the font size, kind of like the pad argument in tight layout. So they are left, right, bottom, and top. So that's the spacing on each side of each respective side of the subplot. W space is the width between subplots, and H space is the height between subplots. So really, this is like the width between, let's see if I remember this, the width between columns and the height between rows. So here we go. We've got the same, we're going to have the same grid here. You can see there's quite a lot of space, even with tight layout pad 0.1. So instead, we're going to manually adjust it, subplots adjust, and we're going to set the horizontal space and the, you see, this is the thing. This is the thing. I always do this, and I'm glad it's happened on camera. I always think that this is the horizontal space between it. Maybe it's because I come from a maths background, but yeah, this is a bit annoying. This, I always think horizontal space, and then I get to W, and I'm like, I think that should be V space, vertical space, but it's not. It's height space and width space. Now remember that Matplotlib is a bit old-fashioned, so it's like everything's in inches, and then you have the height and width with plt.figure. That's it. It's height and width always in Matplotlib. It's never horizontal and vertical. So get that in your head. I still slip up sometimes. So anyway, we're setting the height space and the width space to 0.05 respectively, and you see there's way more space here. Now obviously, you know, this doesn't look very good with these axes overlapping, but you know, you can change them if you want. Maybe this is the same x-axis for all of these and stuff. This is just an example to show you what is possible. And like, to avoid loads of similar examples, just have a play around with this, change these, see what happens, and you'll just get a feel for it. It is quite self-explanatory. All right then, let's move on to the DPI. So that's the measure, it stands for dots per inch, a measure of printer resolution. So that's the literally the number of coloured dots placed on each square inch of paper when it's printed. So the more dots you have, the higher quality the image. And if you're going to be printing your plot on a large poster, you should be using a large DPI. So this is really cool. It's controlled by the plt.rc params dictionary. So RC stands for runtime configuration and params stands for parameters. And if you print this to the screen, let's do this now. What am I doing? Here we go. plt.rc params. There we go. You get a huge list of all these things. And so these are all these are all parameters that are like the default running in the background things that Matplotlib has. So we can see here actually, figure.dpi is 72.0 and face color is white. Here's the default figure size. So that's 6 inches by 4 inches. Automatically has the frame on. All this stuff, you can change it for box plots, and you can actually go in and like manually change this forever in Matplotlib if you prefer certain things, which is really cool. But let's just go over like, and I'll show you how to do that in a second, but let's go over how to like change one specific value. As this is a dictionary, I'll show you here. Oh, well, okay, it's not a dictionary, but it works the exact same as a dictionary. You will, we'll change it now. So I've already shown you that the default value is 72. But here we go, plt.rc params. We can access it by figure.dpi. And then we're just going to plot it with the default DPI. We'll give that a night type. And then we're going to set it, plt.rc params, figure.dpi is 30. So that's less than half. And we'll plot the exact same data, just give it a different title. And we'll see. So these are actually separate plots. You can see by the different plt.show calls. So here's the first one, default, the one we know and love. And if we scroll down, you can see this is tiny, much smaller. And that's what the DPI does. So it's smaller and lower resolution. And if you want to change any of the runtime config, so, oh yeah, quickly, right at the end here, I changed it back to the default. So if I just like set this here, then all the other plots that I make will be that by default because I've changed this one here. Now it doesn't hold between sessions. Every time you do run a new Matplotlib session, it's like the actual RC params dictionary will be loaded. But just in case you do that and don't change it back. So all these parameters are stored in the Matplotlib RC file on your system, and you can modify it. So you can type it in, but if you enter this, import matplotlib as npl, and then npl.matplotlib_filename, fname, it shows you where it is. You can go to that, open it up in Vim or something like that, and edit it. And then you can permanently change the settings if that is something you'd want to do. So subplot spacing, we've covered all of this, tight layout and subplots adjust. Right, let's get on to color bars. So, but before we do, just gonna have a quick sip of water. Got to stay hydrated. So, adding a color bar is the same as adding a title. So you code it underneath the subplot call you're currently working on. So let's just quickly do a 1x2 grid where each subplot is a heat map, and it's just going to be randomly generated numbers. So some of the stuff here may seem a bit complicated, but bear with me. Don't worry. When I looked at this, especially when I was looking through the Matplotlib docs, I was like, what is going on? But don't worry. I'll hold your hand and it will be cool. So also, if you haven't, I'm going to write this in. If you haven't seen my article on the random module, that would be a really good thing to check out. I wrote this on Python's random module. I'm actually using NumPy's random module here, but the ideas are the same. So for example, the first thing we do here is set the seed so we can reproduce our results. If you don't know what that means, check out the random module. It will link it here. Next, we're going to create some 10x10 arrays of random floats. So in the range 0.0 to 1.0. So that's what this function does. We store them in data 1 and data 2. And then I'm just going to make the figure twice as wide as it is long. So remember, it's height over width. So that's why it's that fraction. And then we're going to do the first subplot. plt.subplot 1, 2, 1. And then we use the p color mesh function. We pass our 10x10 array, and we're going to color it blue. And we're going to save that as PCM1, standing for P color mesh, and we pass that to our color bar. We do a very similar thing for this one, but we pass data 2, color it green, second index, all that good stuff. And then, boom, here we go. This is what we get. So a lovely, lovely heat map with our color bars next to it. And the reason also I changed this, I set it to twice as wide as it is long, is that if we run it like this, it just looks a bit cramped and it doesn't look very nice. So that's why. Yeah, so that's it. That's basically how you do it. And also note, let's see, so we'll turn off this color bar. And you see how this is much bigger, and then this looks quite cramped now. So the color bar takes up space from the axis that you are plotting on. So just be aware of that. If you've got, like, for example, well, I'll show you in a second. I'll show you right now. So we're going to create this one that uses one color bar for both plots, but you can see that it doesn't look that great because this one is bigger than this, and so it looks a bit funny. Also, if you haven't seen P color mesh before, check out the docs. We'll probably have an article coming on it soon. I won't go into too much detail here. I think you just pass the data in it and it works. Basically, for this, it's just to get an idea of color bars. But note, this is the same data, but just a different sample, right? So there's just numbers between 0 and 1. So we can actually color these the same and just use one color bar. So the only thing we change a few things. We change the C map to here. We change the C map both to blues, and then we just draw one color bar. So let's just do this right now. So we don't need that one, and we're gonna color this. Boom, and there we go. We get it there. But we'll change this back. Perfect. So, yeah, this behavior can't be changed. This is part of color bars. They take up the space of the axis. But if you draw multiple ones, as you'll see in my subplots article, you'll see that it does work well if you have like a 2x2 grid. That can work quite nicely with the color bars here. So fear not, just test it out, have a play around with the color bars, and you'll get a better feel for it. So final thing to cover is a grid. So that is the number of rows and columns you specify when you call subplot. So each section of the grid is a cell. You can create any size grid you want, but remember, subplot only creates subplots that span one cell. But you can create any size you want using the grid spec class, the subplots function, or subplot to grid method, and I discuss all of them in the subplots article. So really recommend you check that out. So there we go. That's it. That is how you create pretty much unlimited subplots. They are a bit limited, so as long as they take up 1x of the plot, you can do anything you want. So that's amazing. Gives you so much power. You can show so much more on your plots. Makes you look so much more professional. You can control the DPI spacing, set the title. You can really make really impressive plots now. So thank you so much for watching. If you want to learn more about this, if you want to learn more about how I am a freelancer, why I'm teaching you now, really recommend checking out our freelancer course. I took that course and I'm literally now working full-time as a Python freelancer because of it. And if you want to stay tuned, please hit that subscribe button as well. And I look forward to seeing you all and replying to comments soon. Bye.